Hi to all. In this video, we are going to see choice of specific loading for three-phase induction machines. The term P pi represents the total flux. That means total magnetic loading, and is called magnetic loading. Total magnetic loading. Magnetic loading per unit area of the armature surface is called specific magnetic loading. Note that magnetic loading per unit area is the specific magnetic loading, and P pi is the total magnetic loading. Okay, called average value of the flux density in the air gap, BAV. Okay, BAV is the average flux density. Okay, uh, so this is BAV is equal to V pi by pi dl Webers per meter square or Tesla divided by T. Therefore, P pi is equal to BAV pi dl. Okay. Specific magnetic loading. If you go for high value of specific magnetic loading, what are things will occur, and what is the advantage of high value of specific magnetic loading? The things we are going to see in this uh, video. Okay, iron loss. A high value of flux density in the air gap leads to higher value of flux in the iron parts of the machine, which results in increased iron losses and reduced efficiency. If you go for high value of specific magnetic loading, then the high value of flux uh, reduces the efficiency and increases the iron loss. That's one of the important point. Next one, voltage. Okay, when the machine is designed for high voltage, space occupied by the insulations becomes more, this making the teeth smaller and hence higher flux density in teeth and core. Okay, if the high voltage machines works with high voltage, then the insulations needed more space. That time what will happen? That teeth, the that flux density will be high. Okay, that also makes the losses. Transient short circuit current. Okay, a high value of gap density results in decrease in leakage reactance and hence increased value of armature current under short circuit condition. If this short circuit occurs, then the armature current value will increase when high value of magnetic loading. Okay, stability. The maximum power output of a machine under steady state condition is indirectly proportional to synchronous reactance. If higher value of flux density is used, it leads to smaller number of turns per phase in armature binding. This results in reduced value of leakage reactance and hence increased value of power and hence increased steady state stability. If we go for high value of specific magnetic loading, the stability will also increase in that case. Parallel operation. The satisfactory parallel operation of synchronous generators depends on the synchronizing power. Higher the synchronizing power, higher will be the ability of the machines to operate in synchronization. The synchronous power is inversely proportional to the synchronous reactance, and hence the machine designed with higher value air gap flux density will have better ability to operate in parallel with other machines. Okay, some of the limitations we can see when we go for higher value of um, flux density. Okay, flux density in teeth should be less than 1.8 Tesla. Okay, flux density in core 1.3 to 1.5 Tesla. Advantage of higher value of BAV. Size of the machine reduced. Cost of the machine decreases. Overload capacity increases. These are the main advantage of when we go for high value of specific electric loading. Okay, for 50 Hz machine 0.35 to zero point 0.6 Tesla, the suitable value of BAV can be selected from the design data handbook. Okay, these are the things for specific magnetic loading. When you come for electric loading, specific electric loading, the term IA Z by A represent the total ampere conductors on the armature and is called the electric loading. Electric loading per unit length of armature periphery is called specific electric loading. Total electric loading is nothing but represent the total ampere conductors on the armature. Total ampere conductors on the armature is called total electric loading. Electric loading per unit length of armature periphery is called the specific electric loading. The word the letter Q is represented for specific electric loading and BAV for specific magnetic loading. Copper loss. Okay, higher the value of Q, larger will be the number of armatures of conductors, which results in higher copper loss. If you go for high value of Q, the copper loss also will increased. Okay, this will result in higher temperature rise and reduction in efficiency. When you go for the value of Q more, what will happen? The copper loss value will be increased. Because of copper loss increased, the heat, the temperature also increased. Because of the temperature increases, that efficiency of the machine will reduce. Voltage, higher value of Q can be used for low voltage machines since the space required for the insulation will be smaller. Okay, suppose if you go for higher value of specific electric loading, then the voltage, the machine should be small because the current taken by the machine will be less. Okay, if you go for high value machines, then it takes more current. There we should not go for high value of specific electric loading. Synchronous reactance, high value of Q leads to high value of leakage reactance and armature reactions, and hence higher value of synchronous reactance. Such machines will be have poor voltage regulation, lower value of current under short circuit condition, and low value of steady state stability limit the small value of synchronizing power. Okay, steady load, stray load losses. With increase the Q, stray load losses will increase. So we should not go for high value of Q. If you go for high value of Q, the stray losses also will increase. Value of specific magnetic and specific electric loading can be selected from the design data book. Okay, whole machine. Advantage of high value of Q, reduced size. The machine size will be reduced cost. Cost will be reduced. Okay, disadvantage, high amount of copper. Okay, when you go for high value of electric specific electric loading, then the high value of copper is needed. More copper losses will be generated in that, and increased temperature rise because the high current will be flow in that particular area. So specific electric loading will be more, means the temperature rise also will be more. Lower overload capacity, the overload capacity will be reduced if you go for high value of uh, specific electric loading. Normal range, uh, 10,000 AC per meter to 45,000 AC per meter. The suitable value of Q can be selected from the design and data book. Thank you.